Good morning, everybody. Welcome back to lecture number 29. Yeah, 29. Today, we will solve simple op-amp problems. We had the quiz. What was the quiz about? The power triangle problem, okay? We did a problem similar to this problem from the old exams. But here we had 15 kilowatt. The only difference is kilowatt. We changed kVA to k watt. 0.8 lagging, 0.9 lagging, and it was asking. Now it gave you VRMS, but we didn't need to do it by V's and I's. We solved it using the power triangle. Okay? Similar to this problem too. But here we had 15 kilowatt, real power, not apparent power. It is the same problem. So let's do some review about chapter 13. We have two op-amps, okay? The first one on the left, it is inverting, but there is a trick. We also have a negative feedback from the second stage output. So if you remove this resistor, the gain will be easy. Minus 2R over R times V input here. But we have another feedback here. And here we have what? A non-inverting amplifier with negative feedback with a gain of 1 plus R over R, which is gain of 2. So how to solve this example? Well, how to solve it? We are professionals, right? So here we have plus minus, plus minus, plus minus. Now, you do not need to derive everything, but we can do it real quick. The question asks about what is the relationship between V output 1 over V input? Read the question. It's V output 1 over V input. So let's start. We have a negative feedback. Voltage here is 0. Here we have a virtual ground. So what is I input? Or we call it I1. It's Vn over R. I input will be split into two currents, right? Yes. So let's call this I2, let's call this I3, and call this I1. So I1 equals to I2 plus I3. Do you see it? I1 equals to I2 plus I3 because there is no current that enters the op-amp. What is I2? I2 is nothing but 0 minus VO2 over 2R. And what is I3? Same thing, 0 minus VO1 over 2R. 0 minus VO1 over 2R. Then I have to find the relationship between V output 2 and V output 1. So what is V output 2? It is 1 plus R over R times V output 1. How? This is standard non-inverting, okay? Go to the slide. The gain is 1 plus R2 over R1. You remember the non-inverting amplifier? How do you spot it? It's a feedback like this. So this is a stage. The whole thing here, negative feedback, is this thing. This is a non-inverting amplifier. So this implies V output 2 equals to 2 V output 1, right? So now I can use this equation. I1 equal to I2 plus I3 equals V input over R equals, what is I2? Minus VO2, which is minus 2 VO1 over 2R plus I3, which is minus VO1 over 2R. Get it? Now I can find the relationship. If I multiply this by 2, I multiply this by 2, then you will have 2V input equal minus 3 V output 1. So V output 1 over V input equals to minus 3 over 2. And that is how I always do the same mistake, minus 2 over 3. V output 1 over V input equal to minus 2 over 3. Get it? You know how to solve this old exam problem? There is another old exam problem that asks what is the ratio between V output 2 and V input, how to do it. It's very simple. You know that V output 1 over V input equals to 1 minus 2 over 3. So what is V output 2? Is 2.
2 multiplied by V.
No, we know that 2 V output 1 equals to V output 2, so it's half, right?
Yes.
So it's going to be VO2 over 2, this is V output 1, times V input equal to minus 2 over 3. So V output 2 over V input equals to minus 4 over 3, and this is one of the other old exam problems. What was the trick here? Is you have to recognize you have an inverting amplifier here, you have a non-inverting amplifier here, with a feedback from the negative feedback from the second stage out. You have to know that the output V output 2 is the classical non-inverting amplifier. V output 1, you have to calculate it using the circuit analysis, which is what we did here. You cannot say it's minus 2 over minus 2R2, minus 2R over R. You cannot say like that, because you have another feedback coming. But for the inverting amplifier, you only have the standard connection. You can ignore this cable for the non-inverting amplifier. Get it? Get it? Hatem. Let's do another example. Now, you have this circuit. You need to spot, what do you recognize here? Well, we recognize that there is an inverting amplifier up to this point, standard. And here we have another circuit, right?
We have a load.
Yeah, we have a load. The question asks you, what is V output 1? V output over V input. You cannot say I'm going to use voltage divider rule here, because 1R and R over 2, they are not in series. How to solve it?
First, we recognize that we have a virtual ground with the amplifier.
Okay,
So,
you're right. That's good. So can I know the voltage here? Because of the virtual ground? Let's try.
there is no R2 over.
No, that's okay. Because of the virtual ground, R over 2 is parallel with R over 2.
Yes.
And you can calculate this voltage using VDR later. But use, so can I say this circuit looks like this? R, here we have R over 2. Here we have R over 2. I know here is the op amp, but my goal is to find this to be V input prime. This is V input. If I know V input prime, it's very easy. If I know the voltage here, the output is what? 15 over R over 2, which is minus 30 times V input prime. So I know that V output equals to minus 15 R over 2 times V input prime, where V input prime is the voltage drop here. This is like the new input. Let me repeat. You know that you have here an non-inverting amplifier, right? Here I have another system. Because of the virtual ground, I need to know this voltage. This voltage is not VDR between this R2 and 1R. It's actually the VDR between the parallel combination of this R over 2 and this R over 2 in series with 1R. So can I redraw the circuit to be like this? R over 2, R over 2. This is the virtual ground. Can I do it this way? So what is R over 2 parallel with R over 2?
R over 4.
So can I redraw it into this way? And I'm going to call this V input prime. So V input prime equals to R over 4 over R over 4 plus R, this is VDR, times V input. Can I do like this?
Yes.
Which is going to be what? 1 over 4 over 5 over 4. V input, which is what? 1 over 5. The input, right? Plus. This is equal to minus 30. V input prime is 1 over 5 V input, which is equal to minus 6 V input. So V output over V input equals to what? I don't know, let's check. It's minus 6. It's a new problem, right? What was the tricky part? To recognize that this is, I need to know the voltage here. We call it plus minus V input prime. Then you know V output is minus 15R over 2 times V input prime, which is minus 30 V input prime. And then I have to recognize that to get this voltage, I need to have virtual ground here. So R over 2 are in parallel, in series with 1R. I can use VDR. Then I got V input prime, which is equal to 1 over 5 V input. 1 over 5 V input times minus 30 is minus 6. Did you get this? Did you get this problem, Jihad? Okay, you need to rewatch the YouTube video when you solve it. Okay. The last problem is a very easy problem. We have 2 minutes. But clearly, what is this circuit? We did solve it. This is the summer. Summer. So what's the output? You have the equations from the slides. I'm not going to solve it due to time. But it's the summer equation, we just have numbers. Definitely it has minus 3 V2. Definitely. So if you get stuck in the exam, you only have 2 options. Minus 3 V2. So you pick one of those. Of course it's going to be, what is this output? Minus 2 here minus 2 V1, and here is minus 3 times minus 2, so it is plus 6. This is an easy problem. Clearly here the output from the second input is minus 3 V2. Minus 3 times V2. It's the sum. Okay? Do you have questions? So I told you it's a light lecture today. I'll stop the recording now.